Hello, I'm going to help you complete a few calculations. So if you are in seventh period, today is Monday, and if you are in second or fourth period, today is Tuesday. So today you're going to work on calculating speed and velocity. Here are your formulas. Speed is equal to distance divided by time. Velocity is equal to distance divided by time. So I made a few corrections. So number 2, 0.75 hours. Number 8, change this to 120 minutes. Number 9, change this to 0.01 meters per second. So go ahead and make sure that you make those changes. So let's practice a few calculations using the formula speed is equal to distance divided by time, or velocity is equal to distance divided by time. So what is the speed? If the cheetah travels 112 meters in 4 seconds, that is your time. So make your list. Distance is equal to 112 meters. Time is equal to 4 seconds. So velocity is equal to distance divided by time. So put that into the calculator. (112) divided by 4 equals 28 meters per second. How much time would it take? How much time would it take for the sound of thunder to travel 1,599 meters if the sound travels at a speed of 330 meters per second? So that is your velocity. So make your list, 330. Your distance is equal to 1,599 meters. And we do not know how much time. So velocity, so your velocity is equal to distance divided by time. So this time your velocity is 330. Velocity equals distance divided by time. We do not know what time is, so we just write the variable. Now we have to use algebra. So convert this into 2 fractions. Cross multiply. 330 times t. 1 times 1,159 is the same. And now, one more step. We do not have the variable by itself, so we divide both sides by 330. 330 cancels out. T is equal to 1,599 divided by 330. So your time is equal to 4.8. And then the units are seconds. How far? We do not know how far. A person can run 0.25 hours. If they run at an average speed of 16 kilometers per hour. So velocity is equal to distance divided by time. So same thing, similar to this problem over here. And now we cross multiply. D times 1 is D. 16 times 0.25. 16 times 0.25 equals 4. So your distance is equal to 4 kilometers. All right, next problem. So now we're going to, so go ahead and work on these similar to these examples I just showed you. So if you want to pause the video, pueden pausar el video y trabajar en estos problemas, work on these problems. The next one that you're going to work on is acceleration. So here is your formula. Acceleration is equal to final minus initial velocity divided by time. On your paper, you should have these units changed. Same thing here. You're calculating acceleration. So final minus initial divided by time. And that is your answer. So your acceleration is equal to whatever answer you get. So let's practice a few more. So acceleration is equal to final velocity minus initial velocity divided by time. So here we have a motorcycle travels 6 meters per second. After 3 seconds, you have another velocity. So this one right here is your initial. This one is your final. Because first, he's traveling here, then 4 seconds, final velocity. Which of the following was the average acceleration? So what is the acceleration? We do not know. So acceleration, we don't know. Final is equal to 15 meters per second. Initial is equal to 6 meters per second. Time is equal to 3 seconds. So now, final velocity minus initial divided by time. So acceleration is equal to final minus initial divided by time. So 15 minus 6 is equal to 9, divided by 3 is equal to 3. So here, your acceleration is equal to 3 meters per second squared. If a Ferrari with an initial velocity of 10 meters per second and acceleration is 50 meters per second squared, for 3 seconds, so time is equal to 3 seconds, what will its final velocity be? So we do not know what final velocity. Initial is 10 meters per second. So now let's plug into the formula. Acceleration is equal to final minus initial divided by time. Acceleration is equal to final minus initial divided by time. So the first thing we're going to do is cross multiply. 50 times t is 50t is equal to anything times 1 is itself. And now more algebra. Oh, I'm sorry. This right here is 3 seconds. So then 50 times 3, 50 times 3 is 150. So now we are going to use algebra. Now we have minus 10. The opposite is plus 10. Plus 10 on both sides. Cancels out. Final velocity is equal to 150 plus 10 equals 160 meters per second. And so that is what you're working on here. I also made some changes. These should be on your paper. And then one more set of, you're going to read this, van a leer esto. Está en Google Classroom para que puedan copiar y pegar to Google Translate or DeepL. And then answer the questions. So that again is for Monday and Tuesday. And so now this is for Wednesday for 7th period, and then Thursday for 2nd period and 4th period. 7th period, 2nd period, 4th period. So here we go. On Wednesday or Thursday, you're going to calculate Newton's second law, la segunda ley de Newton. Force is in newtons, mass is in kilograms, acceleration in meters per second squared. So here's your formula. Force is equal to mass times acceleration. So let's practice a few problems. So here is your formula. Force is equal to mass times acceleration. 900 kilograms, that is your mass. 20 meters per second, that's acceleration. What is the force? So we don't know what force is. Mass is equal to 900 kilograms. And your acceleration is equal to 20 meters per second squared. So if we plug that into the formula, force is equal to 900 times 20. So 900 times 20 is 18,000. So your force is equal to 18,000 newtons. Number 7, what is the acceleration of Romeo's 900 kilogram force if it moves 100 newtons? So now we have force is 100 newtons. Mass is equal to 900 kilograms, and we don't know what the acceleration is. So force is equal to mass times acceleration. 100 is your force, is equal to mass times acceleration. And so now use algebra to solve for acceleration. Divide both sides by 900. So your acceleration is 0.1. And then what is the mass of Juliet's new horse if the accelerates at the rate of 18 meters per second squared with a force of 78 newtons? So force is equal to 78 newtons. Acceleration is equal to 18 meters per second squared. What is the mass? So force is equal to mass times acceleration. 78 is equal to mass times the acceleration. Divide both sides by 18. 18 cancels out. 78 divided by 18, 4.3. So your mass is equal to 4.3 kilograms. All right, so now work on those problems there. And here we have some kinetic and potential energy problems. We're going to use this formula today, weight times height, which is similar a esta formula. So same as that one. But now we're going to use weight. Weight is in newtons. So here we have, consider a rock weighing 100 newtons. So 200 meters, that is your distance. What is the potential energy? So here's your formula. PE is equal to, weight is equal to 100 newtons, and distance is equal to 200 meters. So P is equal to weight times height. So your potential energy is equal to 20,000. All right, and then number 2, consider a bicycle with a mass of 20 kilograms, traveling at a velocity of 4 meters per second. What is the kinetic energy? Here is your formula. Kinetic energy is equal to 1/2 times mass times velocity squared. So we don't know what the kinetic energy is. Mass is equal to 20 kilograms, and your velocity is equal to 4 meters per second. So 0.5 times mass times velocity squared. So your kinetic energy is equal to 0.5 times the mass times velocity squared. So when you put that into the calculator, 0.5 times 20 times 4 squared, and then hit enter. So that's 160. So your kinetic energy is equal to 160 joules. Consider a flower pot weighing 4 newtons, which is sitting on a windowsill 30 meters. That's your distance. This is weight. How many joules of kinetic and potential energy does it have? So this is your height. So height is potential energy. Potential energy is equal to weight times height which is 120. And the units for potential energy are joules. All right, and so here from problem 3, so from this problem over here, if it falls 20 meters and now you're at this height, what is the potential energy? So really your distance is now 10 meters. So your potential energy is equal to the weight. It's the same one, so 4 newtons. But now we are at 10 meters. So right here it says that it fell 20 meters and now we're at 10 meters. So 4 times 10 is equal to 40 joules. And now question 4, so same thing, use your answer from question 4. So your potential energy is equal to 40 joules. What kinetic energy does the flower pot have when it has fallen 20 meters and is 10 meters from the ground? So now they're asking for what is the kinetic energy. So now we have PE is equal to 40 joules. Oh, let's not do that one. Using your answer from question 5. All right, let's go ahead and stop there. And let's see, Wednesday and Thursday, you are now going to make sure that you use your posters to solve for conduction, convection, and radiation. So in your posters, go to Google Classroom, look under Unit 9, Thermal Energy. And so in these, you're going to determine if it is conduction, convection, or radiation. Also, make sure to use Google Translate. Same thing here. So use your posters, go to Google Classroom, look under the one that says Unit 10, Waves. And so here you are writing the parts of the wave. So which one is the amplitude, the crest, the resting position, the trough, and the wavelength? And then your definitions here. Same thing. So you can use the poster to write your definitions. Usen el poster para escribir las definiciones. Pueden ver la imagen y escribir su propia definición. No lo tienen que buscar en Google. And then finally, you're going to complete some waves calculations. So here you are using this formula. So velocity is equal to wavelength times frequency. There are your units. So use algebra to solve. So here's your velocity. Here is your frequency. What is the wavelength? So velocity is equal to wavelength times frequency. So velocity is 10 meters per second is equal to the wavelength, which we don't know, times the frequency. The frequency is 2.5. So divide both sides by 2.5. 2.5 cancels out. 10 divided by 2.5 is equal to 4. So your wavelength is 4 meters. And so the others are similar. Van a ser similar. And now this last part of the video is for Friday. El último parte del video es para viernes. Para viernes, for Friday, you are going to use this formula. So now you're going to calculate using Ohm's law. So here is your formula. The voltage is equal to the current times the resistance. So what are your units for voltage? Volts. Current is amps or amperes. And resistance is ohms. All right, so here we have 120 volts, 2 ohms. What is the current? So voltage is equal to 120 volts. Current is what we were trying to solve for, and your resistance is equal to 0.2 ohms. So let's go back to the formula. Voltage is equal to current times resistance. So 120 is your voltage, is equal to current times the resistance. So take both sides and divide them by 2. 0.2 cancels out. And you have 120 divided by 0.2 equals 600. So your current is 600 amps. So here, to put this number into the calculator, so you are going to type in 1 second E 3. So one more time, 1 second E 3 when you go in to type in this number. So same thing, make your list for all of the problems. And so they are similar using this formula. And finally, you are going to work on some momentum calculations. So here is your formula. Momentum is equal to mass times velocity. And here are your units. Kilograms times meters per second. The mass is in kilograms, and the velocity is in meters per second. And so again, this is for Friday. Thank you.